Welcome to Sec 1 Geography, Rainforest Adaptations, Plants and Animals. Here is the thing about adaptation questions in the exam. There is one question you will almost certainly get, and it always sounds like this. Name a plant adaptation and explain how it helps the plant survive, or the animal version. Same question, different adaptation, every time. And here is the good news. There is one framework that unlocks every single adaptation question you will ever face on this topic. Name, describe, explain. Learn that structure once, apply it to 9 adaptations, and every adaptation mark in this unit is available to you. That is what this video teaches. Before we look at specific adaptations, let us be clear about what an adaptation actually is. An adaptation is a feature of a plant or animal that helps it survive in its specific environment. Adaptations develop over thousands of generations. Individuals with useful features survive and reproduce. Those without them are more likely to die. In the tropical rainforest, the environmental challenges that drive adaptations come directly from conditions we studied in videos 10 and 11. Heavy equatorial rainfall causes waterlogged leaves. The dense canopy creates near total darkness in the understory. Thin, nutrient-poor soil makes it hard to anchor or feed. Competition for the little available light is intense, and predation risk is high. Every adaptation in this video is a direct response to one or more of these challenges. 3 mistakes that cost students marks on this topic, every exam. Mistake 1, naming an adaptation without describing it. The drip tip helps the plant. That is a name and a vague function, but no description. It scores nothing beyond the name. Mistake 2, describing without explaining. Large leaves are wide and flat. That is a description, which gets 1 mark, but without the explanation of why that width matters, the second and third marks are lost. Mistake 3, a weak explanation with no challenge and no mechanism. It helps the animal survive in the rainforest, that is circular. It says nothing about what problem it solves or how. The fix for all 3 mistakes is the same: name, describe, explain. Every time, no exceptions. Here is what the exam tests. WA, Question 1, 3 marks. Name 1 plant adaptation found in tropical rainforests and explain how it helps the plant survive. WA, Question 2, 3 marks, same question for an animal. 6 marks in total, same framework for both. The examiner accepts any valid adaptation. You choose the one you know best, not the one you think they want to see. Today's roadmap, Chapter 1 teaches the framework. Chapter 2 teaches 5 plant adaptations. Practice. Pause 1 for WA, Question 1. Chapter 3 teaches 4 animal adaptations. Practice. Pause 2 for WA, Question 2. Then, Chapter 4 brings it all together in the cause-effect table. Let us start with the framework. Chapter 1. The name, describe, explain framework, the structure that unlocks every adaptation question. The framework has 3 parts. First, name. State the specific term for the adaptation. Without naming it, you cannot score the first mark. Second, describe. Say what the feature looks like or how it works physically. What would you see if you stood in the rainforest and observed this feature? This is the part students most often skip, and skipping it loses a mark. Third, explain. This has 2 components. Identify the specific environmental challenge the adaptation solves. What problem does the organism face? Then explain the mechanism. How does this specific feature solve that specific problem? This is where the highest value marks are. Knowing the framework means you can answer any adaptation question, including one about a species you have never seen before, as long as you understand the challenge and the mechanism. Let me show you the framework in action using buttress roots. You will see this adaptation again in Chapter 2. Name and describe, 1 mark. Buttress roots are large, fin-like woody structures that extend outward from the base of a tree trunk, spreading up to 10 meters across the soil surface. 1 mark because I named it and described what it looks like. Challenge, 1 mark. Rainforest soils are very thin and nutrient-poor due to leaching, so trees cannot anchor deeply or obtain enough nutrients through deep roots. Mechanism, 1 mark. Buttress roots spread the tree's weight over a wide area of shallow soil, providing stability against toppling and increase root surface area for absorbing nutrients from the thin topsoil. 3 sentences, 3 marks. That is the framework at work. And the same structure applies to every adaptation in this video. Chapter 2. Plant adaptations. 5 of them: drip tip, large leaves, buttress roots, epiphyte, and liana. For each one, I will give you the name, description, challenge, and mechanism, and every one is a complete exam answer waiting to be written. Plant adaptation 1. The drip tip. Name and describe. A drip tip is a long, pointed tip at the end of a leaf that channels water to drip off the leaf surface quickly. Challenge: the equatorial zone receives over 2,000 millimeters of rainfall annually, falling in heavy convectional downpours. When water sits on a leaf surface for too long, it creates warm, moist conditions that promote the growth of algae, mosses, and fungi on the leaf. These colonizers block sunlight from reaching the leaf surface, reduce photosynthesis, and add weight that can physically damage the leaf. Mechanism: the long pointed tip channels rainwater toward the tip and off the leaf rapidly, preventing any pooling. The leaf stays clean, dry, and fully exposed, allowing efficient photosynthesis even during and after rain. Found in the canopy and understory. Plant adaptation 2. Large leaves. Name and describe. Large leaves, or broadleaf surfaces, are unusually large in surface area compared to plants in other climates. Understory leaves are often several times bigger than canopy leaves on the same species. Challenge: the dense canopy above intercepts approximately 80% of incoming sunlight, as we saw in video 11. The understory receives only 2 to 5% of full sunlight. The forest floor receives less than 2%. Plants at these lower levels face chronic, severe light shortage that makes photosynthesis extremely difficult. Mechanism: a larger leaf surface area captures more of the very limited light that filters through the canopy. More light captured means more energy available for photosynthesis, and the plant can survive and grow despite the near darkness, found primarily in the understory and forest floor. Plant adaptation 3. Buttress roots. You already saw the full framework answer in Chapter 1, but let me add one more detail here. Name and describe. Large, triangular, fin-like woody structures at the base of a tree trunk, reaching 5 to 10 meters up the trunk and spreading 10 meters outward across the ground. Challenge: rainforest soils are thin and nutrient-poor due to leaching. Emergent trees reach 40 to 70 meters but cannot anchor deeply. Mechanism: the wide spread distributes the tree's weight for stability. The wide lateral roots also increase the surface area in contact with the nutrient-containing topsoil, maximizing absorption where nutrients actually are, in the top few centimeters, not deep down. This is a critical point. Students sometimes think buttress roots cannot reach deep nutrients. The nutrients in a rainforest are not deep. They are at the surface, exactly where buttress roots operate. Plant adaptations 4 and 5. Epiphyte and liana. Both solve the same fundamental challenge: how to access canopy sunlight without the energy cost of building your own tall trunk. The epiphyte is a plant that grows on the trunk or branches of another plant, typically high in the canopy, but takes nothing from its host. It is not a parasite. It absorbs water from rain, moisture from humid air, and nutrients from debris that collects on the branch. Orchids, bromeliads, and ferns are the common examples. The liana is different, a woody climbing vine that roots in the forest floor and grows upward by wrapping around and clinging to an existing tree. It uses the host's height to reach the canopy, requiring far less energy than building its own trunk. Remember the key distinction: epiphyte roots in the canopy, on a branch. Liana roots in the ground, climbs to the canopy. Practice. Pause 1. Pause the video now. WA. Question 1. 3 marks. Name 1. Plant adaptation found in tropical rainforests. Explain how it helps the plant survive. Choose any plant adaptation from Chapter 2 that you feel most confident about. Write your answer using the framework, name, and describe for Mark 1, the environmental challenge for Mark 2, and the mechanism for Mark 3. Write your full answer before you unpause. When you are ready, unpause for the model answer. Here is the model answer for WA question 1, using buttress roots. Mark 1. Buttress roots are large, fin-like woody structures that extend outward from the base of a tree trunk, spreading up to 10 meters across the soil surface. Mark 2. Rainforest soils are very thin and nutrient-poor due to leaching, so trees cannot anchor deeply or obtain enough nutrients through deep roots. Mark 3. Buttress roots spread the tree's weight over a wide area of shallow soil, providing stability against toppling, and increase the root surface area for absorbing nutrients from the thin topsoil. Check your answer now. Did you name and describe in one sentence? Did you identify a specific challenge? Not just, the environment is difficult. Did you explain a mechanism, how the feature specifically solves that specific problem? If you used a different adaptation, the same 3 checkpoints apply. Chapter 3. Animal Adaptations. 4 of them: camouflage, arboreal lifestyle, prehensile tail, and niche partitioning. Same framework throughout: name, describe, challenge, mechanism. Animal adaptation. 1. Camouflage. Name and describe. Camouflage is body coloring, patterning, or shape that blends in with the surrounding environment: leaves, bark, branches, or the dappled light patterns created by sunlight filtering through the canopy. Challenge. Predation risk is high in the rainforest. The visually complex environment, dense vegetation, layered light conditions, many hiding places, means detection is the central survival challenge for both predators and prey. Mechanism. Camouflage makes an animal nearly invisible against its background. Prey animals cannot be seen by predators and avoid being eaten. Predators can stalk prey without being detected, enabling ambush hunting. Named examples: the leaf-tailed gecko has a body shaped and patterned exactly like a dead leaf. The jaguar's spotted coat matches dappled canopy light exactly. The walking stick insect resembles a twig in shape, color, and texture. Animal adaptation. 2. Arboreal lifestyle. Name and describe. An arboreal lifestyle means living primarily in trees. Arboreal means tree-dwelling. Arboreal animals spend most or all of their lives in the canopy or understory, and they typically have strong gripping hands and feet, flexible joints, and excellent balance for moving through a 3-dimensional canopy. Challenge. The forest floor is dark, has limited food, and exposes animals to ground-level predators. Most food, fruit, leaves, insects, and other animals, is concentrated in the well-lit canopy, where 80% of the forest's species live. Mechanism. Living in the trees gives the animal direct access to abundant canopy food resources while removing it from most ground-level predators. The physical adaptations, strong grip, flexible shoulders, long arms, allow safe, efficient movement through the branches. Examples include howler monkeys, orang-utans, sloths, and red-eyed tree frogs. Animal adaptation. 3. The prehensile tail. Name and describe. A prehensile tail is a long, muscular tail that can grip and wrap around tree branches, functioning as a 5th limb. The word prehensile means capable of grasping. The tail is strong enough to hold the full weight of the animal and provides precise tactile control. Challenge. The canopy is a complex 3-dimensional network of branches at 20 to 40 meters. Falling from this height is often fatal. 4 limbs alone are not always sufficient when you need to reach for food at full arm's length, swing between branches, or carry an infant. Mechanism. The prehensile tail anchors the animal to one secure point while all 4 limbs are completely free. To reach for a fruit cluster, swing to the next branch, or carry a young animal. It works as a permanent safety rope that the animal carries with it everywhere. Examples: spider monkey, howler monkey, kinkajou. Animal adaptation. 4. Niche partitioning. Name and describe. Niche partitioning is the division of resources, food, space, feeding time, or microhabitat, among different species so that each occupies a slightly different ecological niche, reducing direct competition. Challenge. The high biodiversity of the rainforest means many species compete for similar resources. Fruit, insects, and nesting sites are all in high demand. Without some way of separating species needs, the most competitive species would drive others to extinction. Mechanism. Each species specializes in a slightly different food source, feeding height, or feeding time. Because no two species occupy exactly the same niche, they do not compete directly for the exact same resource, and more species can coexist. The classic example, 3 toucan species in the same forest, each with a beak of a different size, feeding on fruits of different sizes. Same forest, same trees, zero food competition between the 3 species. Practice. Pause 2. Pause the video now. WA. Question 2, 3 marks. Name one animal adaptation found in tropical rainforests. Explain how it helps the animal survive. Choose the animal adaptation you know most thoroughly. Write your full answer. Name and describe the challenge, the mechanism. When you are ready, unpause for the model answer. Model answer for WA. Question 2, using the prehensile tail. Mark 1. A prehensile tail is a long, muscular tail found in animals such as the spider monkey that can grip and wrap around tree branches, functioning as a 5th limb. Mark 2. Animals living in the canopy must move safely through a complex 3-dimensional network of branches at 20 to 40 meters. Falling from this height would be fatal. Mark 3. The prehensile tail allows the monkey to anchor itself securely to a branch while using all 4 limbs freely to reach for fruit. Swing to the next branch, or carry offspring, greatly improving safety and mobility in the canopy. Check your answer. Did you include a named example animal? Did you give the specific height, 20 to 40 meters, and the specific consequence, falling would be fatal? Did your mechanism explain what exactly the tail does, rather than just saying it helps? Every specific detail is a mark-earning detail. Chapter 4. The Cause-Effect Table. Mapping all 5 environmental challenges to all 9 adaptations. This is the big picture view that connects everything we have covered. Challenges 1 and 2. Waterlogged leaves and very low light. Waterlogged leaves, heavy equatorial rainfall causes water to pool on leaf surfaces, promoting algae and fungi growth that block sunlight. The plant solution is the drip tip. It channels water off rapidly. No animal solution here since animals do not photosynthesize. Very low light, the canopy blocks approximately 98% of light from reaching the understory and forest floor. 2 plant solutions, large leaves, which maximize the capture of whatever limited light is available, and epiphytes, which bypass the problem entirely by growing on host trees in the canopy. The animal solution is the arboreal lifestyle. Move into the canopy where food produced by light, using plants is abundant. Notice how the challenge links the plant and animal sides. Low light affects plants first, then indirectly affects animals through the food chain. Challenges 3, 4, and 5. Shallow nutrient-poor soil leaching removes nutrients. Tall trees cannot anchor deeply. Plant solution, buttress roots, spread wide for stability and for nutrient absorption across the thin topsoil. No direct animal solution since animals are not anchored to soil. Competition for sunlight, many plants fight for limited light in the lower layers. 2 plant solutions, lianas, which climb host trees to reach the canopy from the floor, and epiphytes, which live directly in the canopy on their host. Animal solution, niche partitioning, which divides food resources so species do not compete directly, reducing the need to fight for the same space. Predation risk, the dense forest creates both hiding places and hunting opportunities. Animal solution, camouflage, which blends an animal with its background to make it invisible. No plant solution in this video, though plants do use chemical defenses in real life. Let us settle the epiphyte versus liana question, because students often confuse them in exam answers. Both solve the same problem, how to access canopy sunlight without building your own tall, energy-expensive trunk. But the mechanism is completely different. An epiphyte starts and ends in the canopy. It takes root directly on a branch, no ground connection whatsoever. It absorbs all its water and nutrients from rain, humid air, and debris that collects on the branch. An orchid 40 meters off the ground with no connection to the soil below. A liana is the opposite. It roots in the forest floor like any other plant, but then climbs the full height of an existing tree, using it as scaffolding. Its leaves reach the canopy, its roots stay in the ground. Epiphyte, canopy start. Liana, floor start, canopy finish. Different route positions, different mechanisms, same destination. One more important connection before the recap. Niche partitioning is both an animal adaptation and an explanation for why rainforest biodiversity is so high. Without niche partitioning, species would compete directly for the same food, the same space, the same nesting sites. In that scenario, the strongest competitor wins and the others go extinct, fewer species overall. With niche partitioning, each species occupies a slightly different niche, different food size, different feeding height, different feeding time. No direct competition means all species can survive, more species overall. This is one of the reasons the rainforest contains 50% of the world's species despite covering only 6% of the land, which we explored in video 10. Niche partitioning can appear in exam questions both as an animal adaptation and as a reason for high biodiversity. Be ready to use it from either angle. Here is your full cause-effect reference table. 5 environmental challenges, mapped to 9 adaptations across plant and animal columns. Waterlogged leaves, drip tip. Very low light, large leaves, epiphyte, arboreal lifestyle. Nutrient-poor, shallow soil, buttress roots. Competition for sunlight, liana, epiphyte, niche partitioning. Predation risk, camouflage. Every row of this table is a cause-effect relationship. Every adaptation in the right-hand columns is a name, describe, explain answer waiting to be written. Use this table when you are revising. Cover the adaptation columns, read the challenge, and try to reconstruct the full 3-part explanation from memory. 4 mistakes fixed. Fixed. Mistake 1, name only. The drip tip helps the plant. Fix, add the description, a long, pointed leaf tip that channels rainwater off the surface quickly. Mistake 2, describe without explain. Large leaves are wide and flat. Fix, add the mechanism. Captures more of the limited 2 to 5% sunlight in the understory. Maximizing photosynthesis in low-light conditions. Mistake 3, weak explanation with no mechanism. Camouflage helps the animal survive. Fix, be specific. Camouflage makes the animal invisible against its background, so prey cannot be detected by predators, or predators can stalk prey without being seen. Mistake 4, confusing epiphyte and liana. Epiphytes grow from the forest floor using trees. Fix, epiphytes root in the canopy on a branch. Lianas root in the forest floor and climb to the canopy. Completely different starting positions. 5 things to remember. 1. The framework. Name, describe, explain. Every adaptation question, no exceptions. 2. The 5 plant adaptations. Drip tip, large leaves, buttress roots, epiphyte, liana. 3. The 4 animal adaptations. Camouflage, arboreal lifestyle, prehensile tail, niche partitioning. 4. Epiphyte does not equal liana. Epiphyte roots in the canopy on a branch, liana roots in the floor and climbs. 5. Niche partitioning reduces direct competition, which allows more species to coexist, which is one reason why rainforest biodiversity is so high. Know these 5 things and you have the full picture of what this video covers. Here's what to do next. Step 1. Download the free learning pack. It has the viewing guide, exit ticket, 2 visual card sets for plants and animals, the cause-effect table, worksheets A and B, and the WA practice set. Step 2. Complete worksheet A on plant adaptations. It uses a photograph description to test your identification and explanation skills. Complete worksheet B on animal adaptations, which includes a matching exercise and a comparison between the spider monkey and the jaguar. Step 3. Attempt the WA practice set without notes, both questions, timed. Step 4. Use the visual card sets to self-test. Cover all the rows, read just the adaptation name and try to give the full name, describe, explain from memory for all 9 adaptations. When you are ready for the next video, watch video 13, Human Use of Tropical Rainforests, Deforestation and its Consequences.